Today we are discussing about the preparation of standard curve. You know that this standard curve is required when we measure or determine the any elements using the indirect methods. Like titration, it is a direct method where we get the data directly after the titration from the burette. However, when we determine the elements using the spectrophotometer or atomic absorption spectrophotometer, at that time we record the standard curve. Standard curve is nothing but it is a relation between the known concentration and the corresponding absorbance. It may be absorbance in case of spectrophotometer or atomic absorption spectrophotometer, and emission in case of the flame photometer. You know the principle of flame photometer, that it is based on the flame emission spectroscopy. Okay, so at that time we will determine the standard curve using the emission corresponds to the known concentration. Okay, from definition, the standard curve is used to determine the concentration of an unknown sample using the known standards. Okay, now where it is required for any analytical chemistry or any biochemical analysis, we have to determine the standard curve. Now, for preparing the standard curve, we have to go for certain steps. The steps: first, we have to prepare a standard stock solution. Before starting the standard stock solution, we will discuss about the standards of chemical. Basically, the chemicals are of two standards. One is called the primary standard, another is the secondary standard of chemical. Primary standard chemicals are those chemicals, those are not changes with the time and space, means they are less reactive to the environmental condition like water, carbon dioxide, and there would be any loss of weight if we kept it for the certain time, but they should be, and their chemical properties remain intact for a longer period of time. These sorts of chemicals are called the primary standards, like potassium dichromate, potassium hydrogen phthalate, sodium carbonate. These are the primary standard. While at the secondary standard are those there that concentration of that chemicals will vary with the time and space. That means the hygroscopic ones. Once we want to go for measuring that particular chemicals, what will happen? It absorbs the moisture from the environment, so the actual weight will be lesser than the weighing weights. So that's chemicals are called at the secondary standards. So for preparation of stock solutions, for any during the preparation of the standard curve, we will use the primary standard. Like one example, if we want to prepare a stock solution of potassium. Now, potassium may be obtained from the potassium hydroxide, and potassium also obtained from the potassium dihydrogen phosphate. But we will take the potassium dihydrogen phosphate because it is a primary standard, whereas the potassium hydroxide, it is hygroscopic in nature. Once we open the box or once we going to weighing this one, then what will happen? It will absorb the moisture, so we will not get the actual concentration of the elements. Okay, now how we will prepare the stock solution? Like we will prepare a stock solution of 100 ppm. 100 ppm means 100 milligram per liter of solution. That means 100 ppm potassium solution indicates that there should be 100 ppm of K present into the solution. And we know that potassium dihydrogen phosphate, from the molecular weight we will calculate the how much of potassium dihydrogen phosphate to get 100 mg of potassium, because 100 mg dissolved in 1 liter of solution, it is called as 100 ppm. Okay, so from the molecular weight, first we will determine the molecular weight of potassium dihydrogen phosphate, taking the weight of potassium as 39, hydrogen as 1, phosphor oxygen as 16. So we will get the molecular weight. So from the X is the molecular weight of potassium dihydrogen phosphate. So in X gram of potassium dihydrogen phosphate, 39 is the potassium. So 39 gram potassium obtained from this much amounts of potassium dihydrogenase phosphate. So 1 gram means 1000 mg, and from 100 mg we will derive, and that amount will be dissolved in 1 liter of solution. And for preparation of a solution, I have told you that first you will, if you want to prepare a 1000 liter, first you take 500 to 800 ml water, thoroughly dissolve the substances within that solution, and then make up the volume up to 1 liter. Okay? In that case, we will prepare the, in that way we will prepare the stock solution. Stock means of stock solution is solution having higher concentration of any elements. It may be potassium, it may be phosphorus, it may be iron, it may be copper, it may be zinc, whatever it may be, but that particular active ingredient of that particular element should be present in that solution. We will call that as a standard solution. Okay. Now, once we prepare the standard solution, I have told you one formula that is called is the V1S1 is equal to V2S2. Okay. Now, why it is required? Because from the standard, we have to prepare a series of solution of lower concentrations, of different concentration, because for preparing standard curve, we required a series of concentration and their corresponding emissions or absorptions. And for preparing, we know from the knowledge of the straight line that for making one straight line, at least 2 points required. And more the points, the more will be the precision will obtain during the preparation of standard curve. Okay. So normally we are taking at least 5 to 6 number of standards. Like from 100 ppm we will prepare 10 ppm, means where no potassium stock solution will be given, only distilled water will be given. And from the after that 10 ppm, 20 ppm, 40 ppm, 60 ppm, 80 ppm, and will be prepared. These are called as the working solution. Okay, understand what is the difference between the standard solution and the working solution. Okay, those we are going for the analysis, these are called working standard solutions. Okay, now once we prepare the standard solution, correspondingly we will take the reading in a particular instrument. It may be flame photometer, it may be spectrophotometer. Okay, now once we get the data, how we will get a series of data. One is x in horizontal axis, or x axis we will put the concentrations, and in the vertical axis we will put the absorbance or emissions. Okay. Now accordingly we will put the points correspond to the concentration and the emissions. It will looks like a dots oriented in a specific fashion. Okay. Now one thing in the introduction I have told that here it is a use for the limit of detection. First point, that the use of the limit of detection means most of the standard curve are the straight line equation. Okay, means there will be a proportional increase. If the concentration increase, correspondingly the absorbance will increase. Okay. Now what is happen in the higher concentration, the linearity will be break. Okay. So in that particular case where the linearity is breaks, or where the curve changes its curvature, is called as the inflection points. Inflection point is what? Where the curve changes its curvature. Okay, here you see that in a point it is somewhat curvilinear, breaks loose its linearity. You see that is point as a limits of linearity. That means up to 10 ppm we can measure, or this standard curve can be applicable for the determining the unknown sample having the concentration of up to 10 ppm. Okay, from this graph. In your case it may be 60 ppm, it may be 80 ppm, but where you see that is a curvilinear appearance or straight line appearance is vanished, then curvature will come, or any inflection point is come, at that these points will be the region for the standard curve. For in that case 0 to 10 ppm is your linearity, and that is to be used for the determination of unknown samples. Okay, because we know that the formula of linear equation is the y is equal to mx plus c. Okay, now and the curvilinear equation or non-linear equation are different. It may be hyperbola, it may be parabola, it may be sine curve, it may be cosine curve, whatever it may be, but it may not be y is equal to mx plus c. In y is equal to mx plus c, that is called straight line equation. There y is the dependent variable, x is the independent variable, m is your slope and c is your intercept. Okay. Now from the knowledge of the basic elementary statistics, we know how we will determine the slope from the least square equation. This is the formula where we can determine the m, and after determining the m we will determine the c. So we will get a relationship, enough, y is equal to some values of m, x plus some intercept. Okay, in ideal cases intercept will be 0. Okay, because the 0 where the no element is there, there should not be any absorbance or emission if it is pure system. So ideally the equation must be 0. That means line passes through the origin. Okay, but somewhere if it is error is come, then in that case we will get some intercept, but always it should be passes through the origin. So in that case the equation will be y is equal to mx only. Okay, up to this clear, friends? Okay, now once we determine this one, we will get a relationship. And in first slide I have showed you, I have written that the created from instrumental response to set a standard sample at a range of concentration and then feed to a function. Straight line is also a function, feed to a function to enable the prediction of unknown concentrations. Okay, now from the, and once we get the equation, in that case you see that this is a straight line equation we get. Now if we get the absorbance of the unknown sample, we know that if we get the unknown sample means we have the y. Then for least square method we know first we have to take a parallel line to the x from the point of y, where it meet with the standard curve. From that we have to take one vertical line to the x-axis, and where the x-axis touches this line, this amount or this concentration will be your concentration of the unknown sample. Okay, in this way we will determine the standard curve. Now you will do yourself that you have a stock solution of 1000 ppm of P solution is there. Okay, now write down the question. You do yourself first the calculation of determination of working standard. You have a stock solution of 1000 ppm. From that you have to prepare the working solutions of 10 ppm, 20 ppm, 40 ppm, 60 ppm and 80 ppm of 100 ml volume. Means हर एक वर्किंग स्टैंडर्ड जो होगा those will be of 100 ml. Okay, 100 ml 10 ppm solution, 100 ml 20 ppm solution, likewise 100 ml of 80 ppm solution. Now calculate V1 S1 is equal to V2 S2. Now what will be your V1? V1 का वैल्यू क्या होगा? V1 क्या होगा? Unknown है. S1 is 1000. V2 is first 100 and S2 is 10. 10, 20. So accordingly determine how much will be the amount of stock solution you have to take. 1 ml for the 10 ppm, 2 ml for the 20 ppm, 4 ml for the 40 ppm, 6 ml for the 60 ppm and 8 ml for the 80 ppm. Okay, and after that you have to make up the volume using the distilled water. Never use the tap water, because tap water also may contain the same element, so it will invites the error in your analysis. Okay, now these things we will do in the laboratory now.